The graph below shows the motion of a semi-truck. Use the graph in your knowledge of science to answer any questions that follow. So first of all, anytime we see a graph, we need to look at what kind of graph it is. This is a distance versus time graph. So this is like our motion detector lab where we were moving away. As I'm looking at this, I can see that in this case, we're moving away. Here, we're moving away still because our distance is still going up, but it's at a slower speed. And then over here, we're also moving away. This would be our fastest speed. We know that because it is the most steepest. So let's read the question. It says, how far did the semi-truck travel in miles in the first 8 hours? So this one should be pretty easy. Let's go ahead and go to hours. We're going to follow that up over here. And they want to know how far that goes. This one is in between 300 and 400, so it should be 350. There is no other kind of, they don't want us to calculate speed or anything, so this is our answer. However, if we did want to calculate speed, we would take 350 divided by 8, and that would give us our speed in miles per hour. So the correct answer is 350 miles. Number 21, a student jumps off a sled towards the west after it stops at the bottom of an icy hill. So we've got this person who is jumping off of a sled based on the law of action-reaction. That's Newton's third law, that for every action there's an equal and opposite reaction. Okay, so in what direction will the sled most likely move as the student jumps off? Well, her action was to jump this way. This is my action. So the reaction is going to be the sled moving off in this direction. That should be the reaction. So if her action was to the west, equal and opposite is going to be the east. So my correct answer is C. Okay, this is number 22. The graph below shows the motion of a golf cart in a straight line. Use the graph and your knowledge of science to answer the questions that follow. So again, the first thing we need to do is look at what type of graph this is. This is a distance versus time graph. Again, moving away, right here, moving away at a much faster speed. It slows down by still moving away, moves away a little bit faster, and still moving away. So the fastest one right here is going to be this one right this little section because, again, it is the steepest. How far did the golf cart travel in meters for the first 8 seconds? So we're looking over here at 8 seconds. We come over here, and we follow it around. It's in between 180, so that's going to be 90. Again, this is going to be 90 meters. That's all they want to know is how much distance they traveled, so we don't need to calculate speed or anything. But if we did, it would be the distance of 90 divided by 8.
Okay, number 23. 4 boxes are sliding with a constant speed before each box experiences an unbalanced force of 8 newtons. Unbalanced force of 8 newtons. Which box would experience the greatest acceleration when the unbalanced force is applied? So we need to come to our trusty formula chart. We're going to look for the formula involving force, mass, and acceleration. We know that if we use our triangle, which we all should have drawn on our test to begin with, we are looking for the acceleration. So if we cover up the A, then our formula becomes A equals F divided by M. So now we just have to come over here and solve for the acceleration for each of these boxes to prove which one is going to have the greatest acceleration. The force is the same for all of them. It would be 8 newtons. So here we have an acceleration, sorry about that, acceleration equals 8 newtons divided by 2 kilograms, giving us an acceleration of 4 meters per second squared. In the second one, we have 8 newtons divided by 4 kilograms, equaling 2 meters per second squared. That's a little smaller than that one, so that's not the answer. Then we have 8 newtons divided by 6 kilograms equals 1.33 repeating meters per second squared. That's, again, smaller than 4, so that's not our answer. And this last one, we have 8 kilograms divided 8 newtons, 8 newtons divided by 8 kilograms, giving us an acceleration of 1 meter per second squared, smaller than 4, so this is not our answer. And again, if we go back to Newton's second law, we know the one with the smallest mass, if forces are all equal, is going to have the greatest acceleration. So we could have answered this without the math, but we just proved it that that is definitely the correct answer. Number 24, Phil is riding his bike to his friend's house, which is 5 kilometers away. He leaves his house at 3 p.m. and arrives at his friend's house at 3:30 p.m. At what speed in kilometers per hour was Phil driving? So let's see. First of all, what are we being asked to find? At what speed? In order to find speed, we look at our handy formula chart, and we know that speed is equal to distance divided by time. So let's go back to our problem. Phil is riding his bike to his friend's house, which is 5 kilometers away. 5 kilometers is a distance. He leaves his house at 3:30 and arrives at 3, and he arrives at 3:30. Well, those are 2 different times, but the total time elapsed is a total of 30 minutes. We know that to get from 3 o'clock to 3:30, it takes 30 minutes. But we need to pay attention to units because the question asks us to answer in kilometers per hour. Well, if we just convert 30 minutes into an hour, if I told you we had 30 minutes left in class, how many hours would that be? That would be 1/2 of an hour. So it would be 0.5 hours. So we come back here, plug in our 5 kilometers divided by 0.5 hours, giving us a total speed of 10 kilometers per hour. Number 25, a marble is given potential energy by being placed at location W. When the marble is released, it rolls down the track. At which location does the marble have the most kinetic energy? We've already talked about potential energy is due to position or height above the earth. So the most potential energy is going to be at this spot right here. Kinetic energy, on the other hand, is due to speed or motion. So if we look at this, if you've ever ridden on a roller coaster, you know the fastest that you are ever going on the entire roller coaster is right at the bottom of the highest hill, which in this case is going to be X. After that, you're going to slow down up to Z. You might speed up again over here at this section, but it's never going to be as fast as it was right here. So location Y is going to be where you have your highest kinetic energy.